Monte Carlo simulations of PCB impedance allow you to predict the variation of trace impedance over a production run of PCBs. Si8000 and Si9000 now include this capability, which you can see in the following slides. Here's how the Monte Carlo analysis works when you use the Si8000. You set the number of iterations and simply calculate. So here I've set just a small number, 10 production runs. So 10 boards produced, and you can see we've got a variation between 48 and 50 and a half ohms. But if I run, say, 100, the data starts to get a little bit more meaningful, and you can see 100 boards being produced and see the impedance variation over the range, and it's beginning to look a little bit more like a normal distribution. If I now ramp this up and simulate 1,000 boards, you can see the statistics starting to build up in the background. While that's running, I'll explain a little bit more. The tolerance is taken from each of the parameters that are fed into the field solver. You can obviously set the tolerance to an appropriate level, and then you can run the tolerance for each parameter randomized with a uniform distribution, or more realistically, you can use a normal distribution. So each tolerance is swung from its min to its max, multiplied by a random number, which is normalized to a normal distribution. You can either set to tolerance, or you can actually set that the tolerance is calculated as a 3 sigma of the standard deviation. So you can calculate a standard deviation from the tolerance figure. When the analysis is complete, then you'll see the summary of the nominal, minimum worst case, maximum worst case, and the Monte Carlo analysis showing you the mean and the standard deviation for the whole of the production run. Here you can see in the background the waveforms are building up very nicely into what you would expect is a normal distribution, as each parameter is swung at random through a normal distribution. You can adjust the tolerance to reflect real life. For example, often the coppers are made to be close to their nominal minimum thickness, and so you can set the copper to be its expected deviation. Or if you know more about each material than the datasheet predicts, you can modify the inputs to the Monte Carlo analysis to get yourself a realistic picture. And now you can see the analysis is complete. We've got a mean of 49.97 ohms with a standard deviation of 1.25 ohms. And you can see of this run of 1,000 PCBs between 46.5 ohms with a nominal of 50 ohms well in the center, up to a maximum of 53.5 ohms. This capability is included as standard in both the Si8000M and Si9000e 2019 editions onwards.